Good morning. This is Mrs. Wells. These are your notes for Tuesday, April 28th. This is a brand new lesson today, guys. This is solving a multi-step equation with variables on both sides. We were used to solving equations where we only had one variable term. We only had one x, and it was either on the right side or on the left side. And we did inverse operations. We added or subtracted, and then we divided. Okay, but we're going to add in an extra step because today we have a variable term, not just on one side, but on both sides of your equal sign, which means we have two variable terms that we need to combine together on one side of your equals. So let's take a look at what I'm talking about here. Okay, here's an example. I have 3x plus 5 equals negative 8x plus 10. As you can see, I have a 3x on one side, and I have a negative 8x on the other side. Okay, I don't just have, like what you were used to seeing last week is something like this, where we just had 3x plus 5 equals 10, and you could solve it. But now today, and this week, and next week here, we have a variable on both sides of your equal sign. So how are we going to solve this? How are we going to combine this? Well, we have some steps just like we did with a two-step equation. And if you didn't notice, this does say multi-step equations. Okay, so we don't just have two steps, we have three steps here for today. So our first step says to add or subtract the variable terms to move to the same side if needed by taking the smaller variable term to the larger variable term. And this is going to sound silly, but this says baby bear wants to meet his mama bear. And I know that you're like, oh, geez, what does that mean? Okay. And it's these kind of silly little things that really make us understand a harder concept. So if you think about a baby bear and a mama bear, okay, put that image in your head. Okay. You have a mama bear and you have a baby bear. Well, obviously the baby bear is smaller than the mama bear, right? So in relation to this math problem, if I look at my two variable terms, I have a positive 3x and I have a negative 8x. If you look at the coefficients, and again, the coefficients are the numbers that come before the variable, I have a 3x, I have a 3, and I have a negative 8. If you compare 3 and negative 8 is smaller, right, than 3. Negative 8 would be considered your baby bear, and 3 would be considered your mama bear. And in nature, the baby bear wants to meet his mama bear. Okay, so in relation to math, what we need to do is take that baby bear of negative 8, and I want to go and take it over to the 3x. And on the next slide, I'm going to show you how to do that. Okay, after you take the 8x, this negative 8x over, and I'm going to show you how to do it again. Okay, after you do that, you've already combined your x's. After that, that turns into a two-step equation where you're going to add or subtract, and then you're either going to multiply or divide. But on this slide, I want you to understand what the baby bear, mama bear scenario is. Again, a baby bear is the smaller of your variable terms, and your mama bear is the larger of your variable terms. And you're looking at the coefficient. Okay, so let's take a look at the next slide, and I'll go through this same example with you, and I'll help you to understand this. Okay. Okay, looking at this problem might not be the same exact problem that we were looking at, but it's a similar problem. When we solve this equation, first thing you do with every equation, we always put that line down the middle. And right now, this honestly will help us to separate our equation into two sides so that we can see specifically the variables on both sides. Okay, so right now, I have a positive 5x on one side, and I have a positive 2x on the other side. So I'm going to look at those specific variable terms. I have a 5x and I have a 2x. I want to look at just their coefficients. I have a 5 and a 2. 2 is smaller than the 5. 5 would be considered your mama bear, and 2 would be considered your baby bear. Okay, right? Because 2 is smaller than the 5. So in order to combine my variable terms on opposite sides of this equal sign, I need to take my baby bear over to the mama bear. When you cross the equal sign, anytime you cross the equal sign, you always have to take the opposite of that number that you're taking over the equal sign, over the line. Okay, so what is the opposite of a positive 2x? Well, the opposite to get rid of a positive 2x would be a negative 2x, right? So I want to take a negative 2x to both sides. So that would cross out my positive 2x and my negative 2x on my right side. And then on my left side, what am I left with? Well, I'm left with a positive 3 because I didn't do anything with that on the left side. And 5x minus 2x is a positive 3x. And then I bring down my 9, but if you notice, I can't forget about that negative there. I brought down the negative 9 as well. Okay, so again, what I did, the baby bear was my 2x. So my 2x, I took over to the 5x. My baby bear wants to meet its mama bear. Anytime you take a term across your equal sign, you have to make it its opposite. And why you have to make it its opposite is because you want it to go away. And when you take it over, you're only adding it to the same type of term that you're allowed to combine it with, which is a variable term. Don't take the 2 over to the 3 here, okay? Because that's a constant term. So 5x minus 2x is a positive 3x, okay? So now my next step is a two-step equation here. So what I do is this is a positive 3 here, and I'm going to subtract 3 from both sides. And why I did that was because that was a positive. Again, I am taking this positive 3 over to the other side. And when I do that, I'm taking it across the equal sign. So instead of this being a positive 3, this is now a negative 3. Okay? And those positive 3 and negative 3 will cross out. I bring down the 3x, and negative 9 and a negative 3 is a negative 12. And our last step in all of these problems here, at least for today, is going to be to divide. And why am I going to divide? Okay, if you're still having problems with this last step here, I'm dividing because this is a multiplication problem. This says 3 multiplied by x. We normally don't write it, but this is the same thing as saying 3 times x. So when you have a number and a letter right next to it, that's multiplication. Okay, so then in order to continue solving this problem, you're going to divide by 3 on both sides. So then the 3's will cross out, and then on the left side, and then you're left with x equals negative 4, because negative 12 divided by 3 is negative 4. And that is your final answer. Okay, so again, just to recap real quick, what I did first was I saw that I had 2 variables. You have to combine the 2 variables onto one side. So an easy way to do this is to take the baby bear to the mama bear. Take the smaller variable term to the larger variable term. And when you take it across the equal sign, you have to make it its opposite. And then that turns into your two-step equation. And from here, you should know what to do. Okay. Now you might think, okay, well, I don't know if I'm right, if I'm wrong. How can I check my work? Well, in order to check your work, you can take your answer that you just got and put it back into each one of your x's. And I'm going to walk you through that step. So our equation was 3 plus 5x equals 2x minus 9, right? So on my left side here, I'm going to just rewrite my problem, putting in the negative 4, which was my solution, into the equation. Okay, so I'm going to draw my line going down so that you can see the left side versus the right side. So now on my left side here, Order of operations tell me I have to multiply first. So when I multiply 5 times -4, I get -20. So that's 3 minus 20 over on my left. And on my right, 2 times -4 is -8. And then I have -8 minus 9. So then let's do the subtraction here. So 3 minus 20 is a -17. -8 minus 9, do the math, that's also -17. When you substitute it back in, the left side and the right side have to equal one another. Okay? And it is a good way to check to make sure that you have it right. And let's say you had 4, but not -4. If you put it back in, you're going to see that those two are not going to equal one another. So make sure you do double check. And some of these problems here, guys, you're going to have to want to write this down. I know a lot of you want to try to do this in your head. Get out a piece of paper, scratch paper, something, a napkin, a paper towel, something. Write it down and figure it out on a piece of paper. Check your work. It's going to make a big difference. Okay. Now, that's not the only problem we're going to go through. We're going to go through many problems here. So let's take a look at the next one. All right. We have 6x plus 7 equals 13 plus 7x. First step we do on all these problems, we always draw that line going down. Okay. Now, as you can see, this is not a two-step equation. This has a variable on both sides. So first step to do is take a look at your variables. I want all my variables to be together. So I have a 6x and I have a positive 7x. Always use the sign that comes right before it. That's a positive 7x. All right. Think about the baby bear, mama bear. If you have a 6 and a 7, 6 is less than 7, right? So 6 would be your baby bear, and 7 would be your mama bear. And if you think about baby bear, mama bear, the 6 has to go to the 7. So I'm going to take the 6 to the 7. In order to do that, anytime, I'm telling you this, guys, anytime you take this any term across the equal sign, you have to make it its opposite, because you want it to disappear on the side that you're getting rid of. So that 6x, you have to make it a negative 6x on both sides, because and again, in equations, what you do to one side, you have to do to the other. So that 6x and negative 6x go away. Okay, that becomes 0. So then what we're going to do is we're going to bring down the 7, right? We're going to bring down that 7. We're going to bring down that 13. And 7 minus 6 is that 1x. And some of you might not want to write 1x. Some of you just write x, and that's fine. Okay. So now this is a two-step equation. This is what we were used to solving all last week. So from here, we're going to take our constant term and take it to the other side. I want to leave my variable alone right now. I already touched my variables. I took them to the other side. Baby bear, mama bear, they're fine. So now I want to take my constant term of 13 and take it to the other side. And again, when you're taking a term to the other side and you're crossing it over the equal sign, you have to make it its opposite. So since this is a positive 13, you want to make it a negative 13 to both sides. And by doing that, that crosses out. Okay. And so then what are you left with? Well, 7 minus 13 is negative 6. And then we just bring down that 1x. And again, this is now your last step of your equation. This is 1 times x. To get x by itself, we're going to do the inverse of multiplying, which is to divide. And so what are we going to divide by? We're going to divide by the coefficient. Again, the coefficient is the number before the variable. So I'm going to divide both sides here by 1. So the left side by 1, the right side by 1, and negative 6 divided by 1 does give us negative 6. So negative 6 equals x. And if you're unsure if you solve that correctly, you can substitute that back into your equation. Okay. If you need to stop and rewind that, go back through that problem, go ahead. I'm going to go through a few more examples, though, with you to make sure we're understanding this. So let's take a look at another one. So we have 7 minus 8x equals 4x minus 7. Next step to do, line down the middle. When you put the line down the middle, you're separating your two sides of your equation. If you look at it, I have a 4x on my right, and I have an 8x on my left, but you have to be very careful here. I said 8x, but there was a subtraction sign there that has to be included. That subtraction sign makes that 8x a negative. So now if you're comparing and trying to find out which one is your baby bear, which one is your mama bear, which one's smaller, which one's bigger, well, my baby bear is -8. -8 is smaller than my 4. You have to look at those numbers that come before the variable, and you have to include the sign that comes right before it. Okay, so -8 is your baby bear. Your baby bear wants to go meet its mama. Okay, so this -8 is going to go over to the right side. And when we take it over, am I going to take the -8x over? Or am I going to take a positive 8x over? That's a very common mistake that we see. When you're taking something across the equal sign, you have to make it its opposite. So when I take it over, I have to make it a positive 8x. When I take that over, by taking the positive 8x over, the positive x and the negative x cross out, okay? And so then I'm left with 7. I bring the 7 down on the left, and a 4x and an 8x gives me the 12x. And I bring down the 17. But if you notice, I also brought down that negative with it. So it's not just 17, it's a -17. So I have 7 equals 12x minus 17. At this point, this becomes your two-step equation that you were used to solving last week. So at this point, what am I going to do? Well, the baby bear and mama bear have met now, and they want to stay put. So now I want to take my constant term. Your constant term here that I want to get rid of is this -17. So I want to take this -17 over to the 7. To do that, I need to make it its opposite. Anytime you cross that equal sign, you have to take the inverse. So the inverse of a -17 is a positive 17. Okay, so the -17 and positive 17 on the right cross out, and 7 and 17 is 24, and we bring down the 12x. As you can see, this is 12x, which means 12 times x. To get x by itself, I need to divide both sides by 12. And then your answer is x equals 2. And I'm going to say this again just to remind you, if you need to check your work, substitute that 2 back into both x's in the original problem. Okay, and when you do that, the left side and the right side should be equal, which they will be. Okay, let's do a couple more. Here's another one. So I have 13 minus 4x equals 1 minus x. Now, when you look at this, you might think, well, I have a 4x and then I have an x, but what's the number that comes before it? Okay, well, if you need to, you could put a 1 before the x. Sorry, it's a little squiggly, but that's a 1. Okay, now I kind of showed you a little bit ahead of time here, but I have a -4x and I have a -1x. All right, which one's your baby bear? Which one's your mama bear? I have a -4 and a -1. Well, -4 is your baby bear. And you might be like, well, why is that my baby bear? Okay, why is the -4 the baby bear and why is the -1 the mama bear? Well, if you think about a number line, okay, think about a number line. Here's 0. And then you have -1, -2, -3, -4, right? Well, the closer you are to 0, the higher the number is. The further away you are from 0, the smaller the number is. So -4 here is further away, which means that's smaller than that -1. So that's why if you see here, I took the positive 4x to both sides. Okay, so I took the negative 4x over to that positive, or I'm sorry, to the negative 1x. Negative 4x over to the negative 1x, and that's a 1 there. Okay, if you don't have a coefficient before a number, you can always put a 1, but be careful because that is a negative, not just a positive, that is a negative. Okay, so since I took the positive 4x over, what happens? Well, my 13 comes down, right? The negative 4 and the positive 4 cross out. I bring down my 1, and the negative 1 and the positive 4x then become 3x. Easy enough, right? And then I am at a two-step equation here. So what am I going to take? I'm going to take, my variable wants to stay put. So I want to take that positive 1 and I want to take it over to the other side. Again, when you take a number, a term, whether it's a constant or a variable term, over to the other side, you want to take the opposite. So I want to make that a negative 1 on both sides. Okay, let me erase that though. Okay, so I'm going to take a negative 1 on both sides. And when I do that, I get negative 12 equals 3x. Okay, so the 1 and negative 1 cross out, negative 13 and negative 1 is a 12, and I bring down the 3x. Again, if you've noticed on every step here, and it will be like this on all of your assignments here, the last step here is to divide by 3. Or I'm sorry, is to divide. And in this case, it is to divide by 3. So I'm dividing by 3 because that's my coefficient with the x. So I'm going to divide the left side by 3 and the right side by 3. And what do we get? Well, 12 divided by 3 is 4. So 3 divided by 3 gives me my x. So I am left with x equals 4. And I can say this a million times here, guys. If you want to make sure that your answer is right, substitute it back inside your original equation for x. Evaluate the expression on the left side, evaluate the expression on the right side. Okay? And they should be equal. Again, if you want to stop, rewind, fast forward, whatever you need to do to help you to understand this. This is the first most important step to solving equations with variables on both sides. Okay? Let's take a look at another one. And for this one here, you're going to see something. All right, so just make sure you're paying attention here. So for this equation, and this is the last one I'm going to go through, I have negative 8 minus x equals negative 3x. Again, put your line going down through the middle. Okay. And what I did is I rewrote that. Okay, because you see that I have a negative x here. You're going to see on your assignment today that there's quite a few questions that have just an x. So I want you guys to make sure that you remember that if you don't see a coefficient, again, coefficient means the number before the variable, that there's a 1 there. But you have to be careful that that subtraction sign also makes that term a negative. Okay, so now if you notice on this, on the left side here, I just have one variable term. Well, that's okay. I mean, every equation looks a little different. So I'm still going to do the same thing. I'm going to take the baby bear to the mama bear, but let's take a look and see what we have. We have a negative 1x and I have a negative 3x. So again, if you think of your number line, okay, if I start at 0, we have negative 1, negative 2, negative 3. Negative 3 here, that's your mama bear because, I'm sorry, that's not your mama bear. That's your baby bear, okay, because that is the smaller term. That is the one that is further away from 0. Negative 1 is your mama bear, okay? Mama bear is bigger because it's closer to 0. It's higher. Okay, and I want to take the baby bear over to the mama bear. So I want to take the negative 3 over to the negative 1. And in order to do that, again, anytime you go across the equal sign, you have to make it its opposite. So the opposite of a negative 3 is a positive 3. I guess I just rewrote that. So a positive 3x to both sides. Okay. When you do that, you're going to see that the negative 3x and 3x cross out, and I bring down the negative 8. So I get negative 8 plus 2x, because negative 1 plus 3 is 2x. And then you're going to see that this is 0. Negative 3x plus 3x is 0. If I did not have this 0 here, you are going to be left with nothing here. Okay? Nothing would be here. That would be empty, which you can't have because you need to take that negative 8 somewhere. So if you ever end up taking the baby bear over to the mama bear and having nothing left, you have to put the 0 there. You still have to put something in that spot. Okay? Now this might be a little confusing, so I'm going to show you something here after I finish this problem. Okay, so my point here was make sure you put the 0 there. Okay? So this is a two-step equation from this point. So you're going to add 8 to both sides, bring down your 2x, so 2x equals 8. And then your last step, like always, is to divide. And here I'm going to divide by 2. And then I get x equals 4. Okay? And again, you can put your answer of 4 back into both of your x terms, and the left side and the right side would be equal. Okay? Now, that might have confused you. And for some people, I know that it probably would. Okay? And that's okay. I'm going to show you something else here. Okay? Okay, so I wrote here, now, as you can see, when you took the baby bear to the mama bear, we ended up with everything to one side, like I said here. How I said that I had to put that 0 there. But the question is, some of you might have been thinking this, well, can you take the mama bear to the baby bear? And the answer is absolutely yes. The only reason why I didn't say that at the very beginning is so that we're doing the problems the same. Okay, that we're taking the smaller variable term over to the larger variable term. And honestly, it's just a little bit easier that way. But there might be some special cases where you might run into, and I want you to be aware of it. But let me go through it where I'm taking the mama bear to the baby bear. So I'm going to redo that problem. And here's the equation rewritten where I wrote in the coefficient of a negative 1x here instead of just having the negative x. Okay. So again, if I look at my variable terms, I have a negative 1x and I have a negative 3x. If I look, we said in the other problem that the negative 3x was the baby bear and I took it over to the 1x. Well, let's do the opposite. And you might be like, well, are we allowed to do that? Again, the answer is yes, you can do that. Okay. But again, anytime you take anything across the equal sign, you have to make it its opposite. So I'm going to not make this a negative 1x to the other side. I'm going to make it a positive 1x to the other side. And when you do that, the negative 1x and the positive 1x cross out. I bring down the negative 8. Nothing changed with that negative 8. It just brings down. And then negative 3 and a positive 1x is a negative 2x. So here, it just might be a little bit easier to understand that way as opposed to having to write a 0 there. Okay. And then this just becomes your final step of a two-step equation. So then I'm going to divide by my coefficient here of now a negative 2. So I'm going to divide the left side by negative 2, the right side by negative 2, and my answer is still absolutely the same. And if you substitute it back in, you are going to see that it works out. The left side and the right side are equal. So again, I would like for you guys to do the baby bear to the mama bear. But if you run into this specific case, which might be 5% of the time, you might have to take the mama bear to the baby bear. Okay. So again, if you need to stop, rewind, rewatch, do whatever you need to do with these examples, please do so. Please come back to them whenever you need to. This is the most important step of solving equations with variables on both sides. Okay. One more slide here that I have, and you're going to be able to access it through the notes, not this presentation. But this is 2 videos that I attached in here. And they're very good at re-explaining what I just did on all 5 of those examples. But my first video, though, says to watch the first 3 examples. The other examples in the video are a little bit more complicated. And if you want to watch them later on throughout the week, you can. But I have it says to stop at the video at 4 minutes and 18 seconds. And then I also have another video as well that you can watch if you access it through your notes, the Google slide presentation that's on your Google Classroom. Okay. Again, if you have any questions, we have office hours every day from 11 to 11:30. The post is on your Google Classroom page every day, and we're here to help you guys. Email us questions, whatever you need to do. Again, this is brand new material, and make sure you're understanding this before moving on, because tomorrow we're going to add another step into it. All right. Hope you enjoyed this, and good luck on your assignment today.